g of 5. That means we put 5 into g, we get an answer out, and we put that back in again. You could work out the composite function g of x and then put 5 in, but it's going to be much quicker to just do the first method I said. So g of 5 is going to be 10 plus 5, so 15. And then 5 minus 3 is 2. So 15 over 2, or 7.5. And that means g of 5 is actually going to be g of 7.5. Double it to 15 plus 5, I'm going to get 20. And then it's 7.5 minus 3, so I'm actually dividing by 4.5. I can times top and bottom by 2 to get 40 over 9. No, that's actually the smallest, so the 7.5 is the value putting in when we put our smallest value of x in. We're asked in part B for the range of g. I actually think this is quite tricky when you're not given the graph. This ends up being a reciprocal kind of function, and I'll show you more about that in a minute. But what it actually tells us is when x is 5, we're taking our maximum value of 7.5. We just then need to think about what happens when x gets large. And actually, what's going to happen is that basically these two terms are going to dominate. The plus 5 and the minus 3 are not going to really come into it. And so we're going to get 2 times a really large number divided by a really large number. And the x is going to cancel out to leave us just with 2. So I'm trying to say that the asymptote on this graph is at 2. And that means the range is going to be 2 is less than g of x, because it can't actually get to 2. And this is less than or equal to 7.5. That value when x is equal to 5. Going into more depth on this, we can actually do a little polynomial division. X minus 3 into, this is going to explain how I knew it was reciprocal. So x is into 2x, go 2, multiply back through, 2x minus 6, subtract, gives us 11 as the remainder. So 2x plus 5 over x minus 3 is equal to 2 as our quotient, plus the remainder divided by x minus 3. That's why it's a reciprocal, because we basically have the 1 over x graph. We're doing a translation, 3 in the x direction, and we're doing a stretch in the y direction. That's not that important, to be honest. And then we're actually going to, so that has this here by itself just has a asymptote at y equals 0, but then we're translating it to in the y direction, which is why everything just moves up and the graph converges towards 2. So you might prefer this approach rather than what I said before, but in any case, it's only for 1 mark, but that is the range, and there's quite a lot going on to get there, I think. Finally, we're asked for the inverse, stating its domain. Actually, we can get the domain straight away. It's going to be the same as the range of the original function. They just swap around because the function takes x to y. The inverse basically takes us back from y to x. So those y values, the range of the original function, become the domain of the inverse. I can write that straight away. 2 less than x less than or equal to 7.5. Now just for the other bit, I'm going to let y equal 2x plus 5 over x minus 3. So at the moment, we know how to get from x to y, but we want to know how to get back from y to x. I'm going to make x the subject. Okay, multiply through by x minus 3. Multiply out the bracket, xy minus 3y is 2x plus 5. Let me just move this away down here. Okay, and then rearrange this. I can write 3y plus 5 is xy minus 2x. I've got to get x on the same side because then I can factorize it out. So x is 3y plus 5 over y minus 2. That's how I get back from y to x. Just for the inverse, we always use x as the input, so we swap it all around. The inverse is going to be 3x plus 5 over x minus 2. coupled with its domain as mentioned earlier.